Hi, welcome to today's tutorial about extracting content using sitemaps. Like we're interested in a homepage and we want to list all the possible links for a website. We can use RSS and ATOM feeds for that, but that only concerns the recent content. And today we're going to see how we can just try to fetch all the possible links a website has to offer if it uses this so-called sitemap protocol. I'll be introducing the web scraping library, and then we will see how we can gather all the links, filter them, and finally we'll get a glance at how we can also perform that from a command line. So the Python library you see here is freely available. You can install it with the pip package manager, for instance. So here we import the part of the library that's dedicated to the sitemap. The sitemap is a file which lists the URLs that are whitelisted for a given site, so to say, meaning that these URLs are safe to crawl. Crawling meaning trying to retrieve all the pages from a given website and to filter them. So this is a big advantage if you can find a website which has a sitemap. This is a pretty common approach here. And we will save a lot of time by using a sitemap instead of crawling URLs or trying to discover them, because all the URLs in the sitemap are supposed to be what we need and not some kind of page which you just stumble upon. Basically, a sitemap URL is an XML file which lists all the possible links for a website along with the metadata, along with additional information. This software package, which I've been working on, enables you to process everything from the start. Here we have a home page. Well, it's convenient, it's sitemap.org, it's the sitemap of the protocol, so they most probably have a sitemap. They do. Here are the links. They are found automatically. And so we've just found about 80 links, which we didn't know about before. Now, what if we know a web page and we already know where the sitemap is? We can also give the URL straight away. It's the case here. And so here are the links. So we see lots of different languages, which takes us to the next question. How do you filter them? Because you will see links, some links you don't want. So we're going to use something Pythonic. It's called a list comprehension. What we're doing here is filtering the links for the string protocol. And here are just the links which feature the word protocol. That's a convenient way to perform this operation. I'm showing this again. So L for L, like link, to be any variable. This has to be the same here. In links, we already have a linked list. And here is a string with a test for a string. Here is another way to use the built-in functions to filter links, in that case by language. You can try to define a target language along with the function that fetches the links. So here is what happens. We discarded about half of the links. I'm going to work on this function in the near future. It's going to get better and better, but here we see we already saved time. We saved time in a double way. First, by listing the URLs of the websites, and secondly, by defining a target language and discarding the languages we're not interested in. So now that we have the links, we can perform a robust extraction on them by so-called web scraping, meaning that we can extract the main text, comments, and the metadata, and we will end with a document collection, so performing the final steps from a home page to a full document collection. Next, we download the links. This takes a little bit of time as the software tries not to put too much burden on the servers. Here is what we have. It's a list of HTML documents, and then we can use this function. We could chain both functions, also like extract, fetch URL, but for the sake of demonstration, I just separated these two steps. And here we're basically extracting the text. Here I found the English text and I'm displaying the beginning of it. So this is how it worked. Please note that we can also choose another format. So here we're using XML we'll see the difference here. So in the first case we have bare text, and in the second case we have XML displayed here with metadata. Here is another form of output, CSV, with tab separated format. You can also export to JSON and XML-TEI instead of XML. So that's all for Python. We will now see how to use it from the command line, and the functions can be used as easily. And here we are retrieving the sitemap from sitemap.org and using a list. The list option prevents you from downloading all the documents and processing them in one go, so you can first examine what's inside. And here as a case study, you can grep for protocol in the list, and here is a subset of the whole list. Now let's say we want to use the links later, so we store them in a linked list, and we will use this file as an input for the library in a second step. Here I'm opening the file and triggering the XML format. I will pipe it to less in order not to see too much text at once. And you can also use the output function to define an output file. So here is what happens. The list is being read, and the documents are not retrieved in alphabetic order. Here is our English text somewhere in the document with a date, which is typical for this document, and the rest of the metadata as described. We can see that structure elements as tables are being kept. That's one of the advantages of this XML output. The whole text has been extracted, including here the code elements for the sitemap. Here we will perform the same operation and see JSON as an output. And here it is. So that's all for today. Thank you for watching this video. Please check out the links below and have a nice time with the library.